Welcome back for part two of our lesson on speed and applications of sound. So, before we get started, here is some speed and applications of sound vocabulary. So, let's review what sound is. Sound is mechanical energy transmitted through compression or longitudinal waves. So, the reason why it's mechanical energy because these waves work through a mixture of potential and kinetic energy. Medium is a state of matter or object that sound travels through. So that's any solid, liquid, or gas that transmits sound. The Doppler effect. The Doppler effect is a change in frequency of sound as the source or observer move past each other. So think about when a fire truck drives past a person. Here's an example. So I hope this is very helpful in helping you understand the Doppler effect. So let's review our videos from part one. Video one was sound and water, where we watched some sound be played over a container of water. And basically, this is just showing how the energy of sound affects matter. Sound amplification through solids was video two. So here's a quick review of what we watched. So what we noticed in this video was that sound traveled easier or traveled more strongly through the solid versus the air. And this is something that basically we notice when we see that sound, even though we can understand sound better through the air, it actually travels easier through liquids and solids. Do ultrasound mosquito repellents work? That was video three. So basically, that video was showing that sometimes we can use sound to repel things or attract things. But in the case of mosquitoes, it didn't work. You're better off using some kind of regular repellent on your skin. So video four was fast NASCAR 200 miles per hour. So let's review this video.
Is up in turn three. Here they come down the line. Green flag about to go back in the air. They'll see the green at lap 57 as they chase Denny Hamlin.
video, you should have noticed that as the cars came closer to the person holding the camera, they became louder. And as they drove past, they were at their loudest points. And as they drove away, the sound became less and less. This is a perfect illustration of the Doppler effect. So, video 5 is ultrasound cleaning in action. And basically, it is just showing how sound can be applied to our daily lives to make them easier. So, our part 2 activities include a video called Real World Science Sound with some questions in the student workbook for you to answer. So, let's watch this video together.
What new discoveries are waiting out there? What new adventures can we see? What are the answers to the never-ending questions in your brain that's in a race to find the reason or the place from deep on Earth to outer space so that the truth of any case can be unfurled in the real world? Science in the real world.
Hi, I'm Kirsten. Welcome to Real World Science. Today, we're going to learn the science behind sound. So get your ears ready because we're going to make some noise. What is You encounter sounds every single day, from the moment you wake up until you go to sleep. Think about all the thousands of sounds you hear every day. Some sounds are awful noises, like that sound you hear when someone scratches fingernails on a chalkboard. Some of these sounds are more pleasant, like music, for instance. We know that if we strum a guitar, it makes a sound. But what exactly is a sound? That's simple. Sound is energy. Here's how it works. When you strum a guitar, it causes the string to vibrate. Vibration is a movement either back and forth or up and down. You can see the vibration if you look at the guitar string up close as it makes a sound. The hitting of a hammer on a bell causes vibrations too. How does the sound get from the bell to your ear? Well, the vibration of the bell disturbs the surrounding air molecules, and the sound travels through the air to your ear in the form of a wave. Those waves travel into your ear where they vibrate your eardrum. The sound waves travel to your ear, and your brain interprets the sound. The same thing happens for any sound you hear, whether it's a musical instrument, or a dog barking, or a siren. The sound waves travel to your ear, and your brain interprets the sound. Pretty neat, huh? Sound waves. To better understand exactly what is happening when you hear a sound, let's take a closer look at sound waves. First, you should know that sound waves have the ability to travel through any medium. A medium is any solid, like the ground, or a gas like air, or a liquid like water. In fact, sound must use a medium in order to travel. So, for example, in outer space, you can't hear anything because there is no air, so there is no medium that the sound waves can travel through. You can better understand how a wave is formed by watching what happens when a stone hits the water. The water is disturbed, causing energy, waves, to go out from the source of the disturbance. Sound works the same way. A sound creates a disturbance and pushes the molecules away from it in the form of a wave. If you could see a sound wave, it would look something like this. A sound wave is a special type of wave called a longitudinal wave. Where the molecules are squeezed together, it's called compression. Where the molecules are stretched apart is a rarefaction. A series of compressions and rarefactions that represent the transfer of energy is called a longitudinal wave. But sound waves can also be represented like this. Notice how the wave goes up and down, with high points called crests and low points called troughs. The crests that you see represent compressions, and the troughs, rarefactions. Measuring sound. We can measure sound in several different ways by analyzing the properties of this longitudinal wave. The first property of sound we are going to discuss is amplitude. Amplitude describes how loud or soft a sound is. The unit of measurement used for amplitude is the decibel, shown as the symbol dB. We can measure amplitude by measuring the height of a sound wave, the distance between the center of the wave and the crest, or the trough. A loud sound might look like this, and a softer sound might look like this. It's important to note that when sound is over 120 decibels, it can be dangerous and your ears know it. At the point the sensation of sound is replaced by a sensation of pain. That's one reason why parents tell you to turn down your music. They don't want you to hurt your ears. Another type of sound property is wavelength. This is the measurement of the distance between two high points or two low points on a wave. Frequency is another property of sound. This is a measurement of the number of waves that pass a certain point in a given time period. Frequency is measured in units called hertz, shown as the symbol Hc. 1 unit of frequency is equal to 1 cycle per second. The more energy a sound has, the higher its frequency. Frequency determines what is called the pitch of sound, how high or low a sound is. A flute, for instance, has a higher frequency and higher pitch than, say, a tuba, which has lower frequency and thus a lower pitch. Did you know that dogs can hear sounds with much higher frequencies than humans? Humans hear frequencies that range between 20 and 20,000 hertz. And dogs can hear sounds with frequencies up to 35,000 hertz. And if you think that's a lot, imagine how amazing bats must be. Some bat species can hear sounds with frequencies up to 100,000 hertz. Sound and hearing is especially important to bats because it helps them to navigate. Bats don't have great eyesight, so they rely on their hearing to navigate by sending out sounds and listening to the echo. An echo is a sound reflecting or bouncing from an object. The process of using echoes to locate objects is called echolocation. By using echolocation, bats can tell how far away objects are, whether it's fruit, a tree, or another bat. Bats aren't the only ones who can use echolocation. Other animals like dolphins use it too. People use the concept of echolocation as well. An ultrasound exam is a procedure that uses high-frequency sound waves to scan a woman's abdomen to create a picture of a baby and placenta. An echocardiogram is the test that uses sound waves to create a moving picture of the heart. What affects sound? Sound needs to pass through a medium in order to travel. It's interesting to note that each type of medium will affect how fast sound can travel. The rate at which sound travels through the air is approximately 340 meters per second at sea level. That's over 760 miles per hour. The speed of sound traveling in air is also referred to as Mach 1. So when you hear people in movies talk about reaching Mach 1 or Mach 2 in a jet plane, what they are really doing is comparing the aircraft speed to the speed of sound. The speed of sound can change depending on what type of matter it travels through. If you take sound into water, it travels faster than it does in air. And sound travels even faster in steel. Why is that? Well, sound is energy, and when sound travels, it's the transfer of energy. When sound travels, the initial energy created from the sound is bounced from molecule to molecule and vibrates outward from the sound source. If we watch a demonstration of sound traveling through air, we notice that it takes a while for the molecules to bounce against each other and transfer the energy through the medium. The quality of a medium that describes how quickly molecules bounce against each other is known as elasticity. Now, if we look at another graphic demonstration where molecules are packed together really closely, you can see that the molecules bounce off each other much faster, causing the energy to move more quickly. That's why sound travels faster in steel than in air or water. Solids are denser than liquids or gases. Density is just a way to describe how closely molecules are packed inside a medium. There's one other factor we need to mention that has an effect on how fast sound travels, and that's temperature. The colder a medium gets, the slower the sound will travel through it. That's because the colder molecules get, the slower they move. And if the molecules can't bounce off of each other as quickly, sound travel is fast. So, what can you do with all this fascinating knowledge of sound? Well, maybe someday you'll become a scientist who uses sonar to study the ocean and marine life. Or you might join a rock band and become a famous musician or singer. But for now, you can hum along with your favorite songs and enjoy the many different sounds you hear in the real world.
So, from that video, you guys can go to the observation notebook and you will see that there are a few questions where it says Speed and Applications of Sound, Part 2. Now, there are a few other videos included on the Part 2, Day 2 Explain section. And these videos are mainly to reinforce what was said in the first video that we just watched. So, Khan Academy Speed of Sound video, as well as the Khan Academy Relative Speed of Sound in Solids, Liquids, and Gases video, again, are used to reinforce the information that was just discussed in the video we just watched together. For part 3, you have a speed of sound quizzes, as well as a Legends of Learning technological applications of sound waves playlist, with some games and other activities that help you extend your understanding of how we use sound in our everyday lives. Lastly, you have the Sound Wave Simulator, which is a video that will help you figure out how to turn your smartphone into a sonar device. Enjoy the rest of the week and see you next time.